Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. My name is Puan Emma Azura binti Abdul Kadir. I am the lecturer in charge for this session to explain about Chapter 6, Circular Motion.
Okay, for starters, let's watch the video for you to understand more about this chapter.
Circular motion is simply the physics of things moving in circles. This happens all the time. For example, you are moving in a circle around the Earth as it rotates about its axis. If you are on the equator, you would be moving through a larger circle per day than if you were in London, which is much further north. However, both of these places would have the same angular displacement at any point in the day. The angular displacement is measured in radians rather than degrees because it makes calculations much more straightforward. For example, the distance you move along the circle is given by the formula S equals r theta, where S is the arc length in meters, r is the radius of the circle in meters, and theta is the angular displacement in radians. There are 2 pi radians in a circle, which means that 2 pi equals 360 degrees, and using this fact we can convert between degrees and radians. For example, an aeroplane performing a loop-de-loop of radius 60 meters turns through 135 degrees. To calculate the distance the plane has moved, we have to first convert the degrees into radians. This is done by dividing 2 pi by 360 degrees to get the radians for 1 degree, and multiplying it by 135, which gives us 3/4 pi, or 2.36 radians. This can then be used to work out the distance the plane has travelled as being 141 meters. When an object undergoes circular motion, the object will move at a constant speed but changing velocity. The velocity is changing because the direction is constantly changing, and the velocity is both speed and direction. This means that there is an acceleration, called the centripetal acceleration. The formula for this is A equals v squared over r, where v is the velocity and r is the radius. Another relationship in circular motion is omega equals v over r, where omega is the angular speed, which is a measure of how many radians are being turned through per second, and is measured in radians per second. Another formula for omega is 2 pi over t, where t is the time period for one complete rotation measured in seconds. A centripetal force must be occurring here in order to produce this acceleration. The formula for centripetal force is F equals mv squared over r, where m is the mass of the body undergoing circular motion, v is the velocity, and r is the radius of the circle. For example, another aircraft display team perform a horizontal circle of radius 350 meters traveling at 100 meters per second. From this we can work out the angular speed as being 0.286 radians per second. If the mass of the pilot was 75 kilograms, then we could work out the centripetal force acting on the pilot as being 2,140 newtons.
Okay, let us proceed to our lecture, Circular Motion. Chapter 6, Circular Motion. In this chapter, there are 2 subtopics, 6.1 Uniform Circular Motion and 6.2 Centripetal Force. Okay, here's the learning outcomes for this subtopic, Uniform Circular Motion. At the end of this chapter, students should be able to describe uniform circular motion and convert unit between degrees, radian, and revolution or rotation. Okay, uniform circular motion. What is uniform circular motion? Uniform circular motion is a motion in a circle or circular arc at a constant speed. Okay, look at figure 6.1. From this figure, you can see S, R and theta. The relationships between S, R and theta given by S is equals to R theta. S is the length of circular arc, and R is radius of the circular path. Theta is angle which the arc subtend to the center of the circle in radian. Okay, next, linear tangential velocity. Linear tangential velocity is directed tangentially to the circular path and always perpendicular to the radius of the circular path. This shown in figure 6.2. Okay, for you to describe uniform circular motion, in uniform circular motion, the magnitude of the linear velocity of an object is constant, but the direction is continually changing, causes the change in velocity. And the unit for tangential velocity is meter per second. There are two parameters involved in this topic. The first one is period. Period is a time taken for one complete revolution, cycles or rotation, and the unit for period is seconds. And the second one is frequency. Frequency is a number of revolution, number of cycles or rotation complete in 1 second, and unit for frequency is hertz or s to the power of -1. So the equation between f and t given by f is equals to 1 over t. For an object to make one complete circular motion, the distance traveled is equals to 2 pi r, and the time taken is equals to 1 period. Formula and unit. In this subtopic, you have to know two formula. The first one, the formula for speed of the body, and the second one is the angular velocity of the body. The speed of the body, v is equals to distance traveled per time interval. V is equals to 2 pi r over t, or v is equals to 2 pi rf. For the angular velocity of the body, omega, omega is equals to 2 pi over t or 2 pi f. The relationship between the speed of the body and angular velocity given by v is equals to r omega. Angular velocity, also known as angular frequency, and the unit for the angular velocity is radian per second. For you to know, pi radian is equals to 180 degree and 2 pi radian is equals to 360 degree. Okay, let's proceed to the next subtopic, 6.2 centripetal force. Here's the learning outcomes. At the end of this chapter, students should be able to define centripetal acceleration, and the second one is solve problem related to centripetal force for uniform circular motion cases, such as conical pendulum, horizontal circular motion, and vertical circular motion. Centripetal force. What is the definition for centripetal acceleration? Centripetal acceleration, ACOAR, is defined as an acceleration of an object moving in a circular path whose direction is towards the center of the circular path and whose magnitude is equal to the square of the speed divided by the radius. In equation, AC is equals to V squared over R, or AC is equals to R omega squared is equals to V omega. The direction of centripetal acceleration is always directed toward the center of the circle and perpendicular to the linear tangential velocity, as shown in figure 6.3. For uniform circular motion, the magnitude of the centripetal acceleration always constant, but its direction continually changes as the object moves around the circular path. Centripetal force. What is the definition for centripetal force? Centripetal force is a net force acting on a body causing it to move in a circular path of magnitude. In equation, Fc is equals to mv squared over r, or Fc is equals to mr omega squared, or mv omega. The direction of the centripetal force is in the same direction of the centripetal acceleration, as shown in figure 6.5. If the centripetal force suddenly stops to act on a body in the circular motion, the body flies off in a straight line with a constant tangential linear. In uniform circular motion, the net force on the system is centripetal force, so the work done by the centripetal force is zero. But the kinetic energy of the body is not zero, and given by the following equation. Okay, here's come the summary for subtopic 6.2. Okay, let's do some examples for you to reinforce your understanding about this chapter. Here are some tips for you to follow in problem solving. This is example 1 for the first case, conical pendulum. Okay, this is example 2 for second case, motion in a horizontal circle. Okay, the last one is for the third case, motion in a vertical circle. Okay, that's all. Thank you very much. I wish you all the best and good luck, and hopefully you'll get A in physics. And Assalamualaikum warahmatullahi wabarakatuh.
Jangan lupa like, share and subscribe video ini. Thank you for watching.